Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 13, Section 2, Part 3. And we're going to finish up our 13.2. And if you remember, we were left with a little bit of a cliffhanger in Part 2, where we were solving for the hydronium concentration of a solution with a pH of 3.5. So, we're going to get out our calculators and put in 10 to the exponent of negative 3.5, and that gives us, it's in scientific notation, so I'll put it in scientific notation first, 3.162, so on and so on, till to 10 to the negative fourth equals. Now, let's look at this. 10 to the exponent of log cancels out. So we have the hydronium concentration left over. So make sure you're writing this down. So I'll put this in standard notation and we'll figure out how many sig figs we get. We get 2. So 10 to the negative fourth would be 0. And then moving it over 4, 1, 2, 3, 4. I'm going to have 3 zeros after the decimal point. 1, 2, 3, and then going over to the 3. And then 0.16 turns into 3.2. So it would be 1, 2, 3, 4, negative fourth. All right, 0.0032, and our concentration, the unit for concentration is molar, equals our hydronium concentration. Okay, let's double check that that is reasonable. So it is between 1, 2, 3, 10 to the negative third, because there are 3 zeros after the decimal point, and negative 4 between 0.000 and 0.00001. It's between those two small numbers. So it'd be between negative 3 and negative 4, but we know logs are opposite. So is it between 3 and 4? It is. So we answered the question, what is the hydronium concentration? And we got a reasonable answer. Okay, let's come back to writing some things down. pH of bases. Yes, bases have pHs, as we know, from 7 above to 14. To find the pH, if you know the hydronium concentration, because if you remember, pH is always hydrogen concentration. But what happens if they give us the hydronium concentration? Well, it's pretty easy, because the pH is equal to 14 plus the log of your hydronium concentration. So let's do an example. Find the pH of a 0.12 molar sodium hydroxide solution. So please write that down. And then the first thing we do is we write our equation. pH equals 14 plus the log of the hydronium concentration. Okay, the next thing we're going to do is we're going to sub in our numbers. So please write this down. The pH equals 14 plus the log of 0.012 molar. And then we're going to, you can grab out your calculator, and the log of 0.012 is about negative 1.92. Let's see, we're going to get 2 sig figs, negative 1.92. I'll put in an extra digit there. And then I want you to find the answer of the pH. Okay, so you should find the pH, and then the pH would be 14 minus 1.92. 14 minus 1.92. So 12.08, and we get 2 sig figs. So that would be 12.1. And I'm going to fix that up. Okay, let's double check that we answered the question and we got a reasonable answer. So find the pH. Yep, we found the pH. And it's sodium hydroxide, which is a base. And is our number bigger than 7? Is it more basic than neutral? Yes, it is. So we got a reasonable answer. Good job. I want to talk about indicators now. Those are chemicals that turn colors, different colors at different pHs. And so it's really good for indicating when there's been a change in pH, particularly if we're trying to do this thing called a titration, where we're trying to get mix an acid and base and neutralize them. So some examples of indicators are phenolphthalein, litmus, methyl orange, red cabbage juice, and there are more of them. So please write down those examples. And yes, we have used phenolphthalein. We put some drops in it, and then it turns pink when it is basic, and then it's clear when it's acidic. And we have done experiments with that. In our next video, we're going to be doing those acid-base reactions, and we're going to be talking about them. I'll see you then. Bye.